So, hello everyone, and thank you for being here. Today, we'll dive together in the wonderful world of render objects. Let me start by presenting you two questions I asked on Twitter about them. In the first one, I asked to the people if they have ever created their own render object. So we can see that there is around 70% of people who never did. Who among you never did? Raise your hand. Yeah. So as you can see, you're not alone. Who already did create its own render object? Okay. So I hope I will learn something to you then. And who knows nothing about render object? Not even that name. Okay, great. So the second question I asked was to the people who never written their render object, their custom render object. Why? So as we can see, a lot of them never did because they never needed to or don't know why. So it's completely normal if it's also the case for you. We can also see that there is about 12% of people who are afraid of them, and I can understand why. Sorry. So I'm Romain Rastel. I'm a Flutter lead developer at Daylin. And my love story with Flutter started at the end of 2017. So it's over 5 years ago now. I know I'm pretty old. Back then, I wrote some packages to Flutter to better understand how Flutter worked. And I wrote some Medium articles about what I did. The first package I created was a custom render object. The package is called Flutter Staggered Grid View, and I have written a lot more since then. I learned how to tame them, how to make them my best Flutter friends for life. Now, when I see a complex layout, I evaluate if it would be better to tackle it with a custom render object or not. So I worked at Daylin, and we are creating a new gamified payment system to improve the relationship between local businesses and users. And we are creating our own chat system. Yeah, we are crazy. And because banking fees are very high, we are also creating our own banking system. We have implemented a lot of many complex screens, and currently we are only deployed in France in 2 locations, and we plan to expand to the west of France in early 2024. So before diving into our subject, let's step a step back and look at the following slide. So at the left, you have what you use in your everyday life, the widgets. They are, they are the blueprints of your views. They describe what you want to do. They are the main part of the declarative paradigm in Flutter. They are immutable, so when you want to change something on your screens, you have to create a new instance of that widget with the properties to change. On the right, you have my best friends, the render objects. They describe how you want to render things, how you want to paint pixels on the screens. They are mutable, so they live much longer than the widgets. And in fact, every time a new instance of a widget is created, Flutter will call a method to update the associated instance of the render object to paint what we want to paint. And in the middle, you have the elements. They are the glue between the widgets and the render objects. They are also mutable, and they are between every build context you have ever seen. And in case of stateful widgets, the state instance is attached to the element. So there are a lot of widgets out there, either in the Flutter SDK itself or in PubDev and packages provided by the community or GitHub. So you may wonder, why the hell would I want to create my own render object? So in my opinion, there are at least 3 reasons why. The first one is because it's impossible otherwise. So let's look at this component. So it's a part of the chat view we have in our application. And let's focus on this kind of stack here. The stack here, we have on the back the content of the message, and above it, we have what I call a reaction bar. So it may look like a simple stack, but look here at the bottom left. In that case, when the message of another chat participant is smaller than the reaction bar, we want to put a small space at the left of the reaction bar. So this is pretty specific, and I don't think we cannot do that without creating our own render object. Another case where it's good to create a render object is performance. So let's look at this example where we have a left gray bar here, and we want this gray bar to be as tall as the widget on the right. I'm pretty sure some of you had this requirement before and ended up using intrinsic height. Am I right? Yeah. But the issue with intrinsic height is that it is relatively expensive. It is directly proportional to the square of the widget's depth 3. So on the right, if you have a big widget tree, it will be a big performance caveat. So I prefer to avoid using it when I can. And at the render object level, we can have the size of the widget on the right. At the same moment, we are on the same frame, we want to paint the left gray bar. So there is any performance problem with that. So it's pretty performant to do this at the render object level. And to finish, you may want to go at the rendering level for simplicity. Yeah, I know it can be pretty confusing because render objects are not known to be simple, but everything is relative. In this example, we want to be able to display up to 5 avatars, and depending on the number of children, we want the size and the position of each avatar will be different. And to me, it was easier to go at the render object level than to create that in the widget one. I'm pretty sure we can do it with a stack or something like that, but it was easier for me to go to create a render object for that. So, as you saw, sometimes the best way to have what we want is to do it ourselves. And for that, we may have to get our hands dirty and create or modify a render object. So today, I will give you some advice to get it down. So let's look at the big picture here. Do you remember this? We have the widgets, the elements, and the render objects. To create a render object in Flutter, we have to comply with this architecture. Fortunately, the Flutter SDK comes with built-in classes, and we'll see together what to choose according to our needs. To create a widget associated to a render object, we have to extend from a class called RenderObjectWidget. And we have 4 built-in types in Flutter for that. To create the render object itself, we have to extend from a render object. And we have 2 built-in types in Flutter for that. And to glue it all together, we need the elements. But Flutter already took care of them in the render object widget, so I won't speak about it. Before diving into specific, let's look at the key principles and how immutability meets mutability. So on the left, you have an example widget, and instead of extended from stateless widget or stateful widget, we'll extend from something called a render object widget. On both sides, you will find the same properties. Height here, and the height is immutable in the widget world, and the height in the render object is mutable. So we will have a backing field, a setter, and a getter. And we have the same things in for the background color. We have to implement two methods in the widget world for that. When the first widget of this type is mounted on the tree, Flutter will call the create render object. The purpose of that method is simply to create the first instance, the instance of the render object we have on the right. And this instance will live as much as there is a corresponding widget in the element in the widget tree. And the second method to call is the method when a new instance of the widget is created. Flutter will call the update render object, and it will pass the instance we have already created in the create render object as a parameter here. And we have to mutate the properties we have in the render object. What I love here is the granularity of what to do when property changes. For example, here, when we mutate the 8, and only when the 8 is different than the one before, we will code a method in Flutter called markNeedsLayout. This method will tell Flutter that the layout of the widget has changed, our size has changed, or maybe other things, and we have to recompute all the layout. So in this case, Flutter will call a method called performLayout after that, and it's in this method that we recompute things. And for the background color, pretty much the same thing, except we don't call markNeedsLayout here because the layout won't change. We only want to paint a different color. And for that, we tell Flutter, we execute the method markNeedsPaint, and with that, Flutter knows that the paint is dirty, and he has to recall the paint method, and it's in the paint method that we actually painting the widget here. So let's dive into the widget side of this. We saw earlier that we need to extend from a render object widget. There are 4 built-in types in Flutter for that, and to choose the right one, we have to focus on the number of children our widget needs. If our widget does not need any child, if its layout depends only on non-widget parameters, then we need to extend from leaf render object widget. As an example, we have this timestamp chat message where we want to put the timestamp, on the last line of the message, and if he has enough space to do that, and if he don't have enough space, we put on a new line. Craig Labence published a great video about render object where he focuses on this example. So if you have never watched it before, I advise you to scan the QR code here and to watch it after this talk. Now, if our widget will have only one child, then we need to extend from single child render object widget. For example, here we have our widget with the left gray bar. So there is only one widget because the left gray bar is only painted on the screen. It's not a widget. Now, you may wonder if my calculations are correct. I talked about 4 built-in types, and to choose the correct one, we have to focus on the number of children. We talked about 0 children, 1 child. Now you may think there is only one use case left, the case of multiple children. Yeah, you are right. But then, in this case, there are 2 kinds of widget with multiple children. The first one is where the widget, the children have an identical meaning. For example, in a row, all children of a row are of the same meaning. They are to be laid out in the same line. And as another example, we have our avatar group here. Each child is an avatar. So in this case, we have to extend from multi-child render object widget. So The last one here is when we have children with different meaning. And as an example, even if it's not built like that in Flutter, we can mention the scaffold. The scaffold has a nav bar, a body, a bottom navigation bar, and so on. We always want the bar to be above the body, and the body to be above the bottom navigation bar. We have to be very specific about that, and we can't insert a nav bar anywhere in the list. So, and for that, we need to apply a mixin called, let me take a breath, slotted multi-child render object widget mixin. This mixin will be deprecated in the next stable version of Flutter and replaced by a widget simply called slotted multi-child render object widget. If you are on master, this is already available. And you remember the stack earlier? Well, in our application, we use a slotted multi-child render object widget mixin for that. Now that we talked about the widget part, let's dive into the dark side, the render object one. As we saw earlier, there are two built-in render objects in Flutter, and I'm pretty sure you may already know them. So let's see how to choose between them. In case if you want to lazily render children in a viewport, or you want to interact with a scrolling system, then render sliver is your friend. I won't go into details here because sliver needs an entire talk, and you can go to the talk of Mikhail Zotyev. It will be in the same room here. It is the last one of today. So I advise you to go to this talk if you want to know render slivers, if you want to have more information about them. So if you don't need a render sliver, and believe me, most of the case you don't, then you need to extend from a render box. Okay, before diving into some code, let's talk about some key points in the render object protocol. So we need to layout our children, and the layout is a part where we compute the size of the render object, and we also compute the position of our children. In the render object, we have a method called perform layout we saw earlier, which is its main job. And there is a difference between a render box and render sliver, but it's mainly in the name and the properties of the component. But the logic is the same. We give constraints to the render object. Those constraints can tell it how much it can be big and how much it can be small. And the layout has to compute the size of the render object. The signature of the perform layout method is strange for me because there is no parameter, no return object. It's a void function. It's a void method. So Flutter expects us to set the size in case of the render box before returning from this method. So if we don't do it, we'll have an error. After that, we want to paint our render object, and to that we have a method called paint. And this method, what is important is that the painting order can give you different results. Because if you have a lot of widgets, the first widget will be paint here, the second one above, maybe can be above it, etc., etc., like in a stack. In a stack, the first widget you put in the list is the one at the bottom. So if you don't want that, you have to be careful about the order of your painting. So it testing is about interacting with your widget. If you want to be able to touch or respond to gestures, and you need to take care of this method here if you want to be able to touch your widget. It's pretty easy to add. There is some sliver helper classes to where the algorithm is already available. but it can be easily forgotten. So if you don't implement it in your render object, it will simply not be touchable. Let's talk a little about parent data. Parent data is a property of the render object, and it's mainly used by the parent of your render object to store some information you will use after the perform layout method. For example, if we have multiple children and we want to position them at different places, we want to store the offset of the top left of our children in that property. Okay, so I know it's a lot of information, but I think I gave the basics to start creating your own render objects. There is a lot more about them, but in most cases, you won't have to dig deeper. I created a little cheat sheet that sum up what I talk about. So at the left, you have the number of children, and on the middle, you have the name of the render object widget you have to use. And on the right, I won't go into details, but you have some classes already implemented in Flutter that can help you to make your job easier. So there are a lot of things here, and you can dive in if you want. So let's try to live coding a render object in less than 15 minutes. Okay. So what we want to do here is to have content and a page above it, but we always want the page to be positioned at 2/3 of the content here. So we can't use a stack because we will have to know the size of the content here at the same time of the rendering. So let's see how to do that. So I will just change here. I have my widget which is correctly working, and I change the name here. Okay, so that won't work. And then here I will create my render object. So to make things quicker, I have a snippet here. So I want to create a content with page widget. Okay, so here we will use a slotted multi-child render object mixin because we have two children here, so the content and the page, and they have different meaning. We can't use a list because we want to be specific about which one is a page and which one is a content. And to do so, we have to use a slotted multi-child render object mixin. We have to provide it an object, and most of the time it's just an enum that will list all the meanings you have in your widget. So here we have a content and we have the page. So we have some methods to implement here. So the first one, child for slot, is used to tell if we give a slot, which is the widget we want. But before, we have to create our widget here. So the first widget will be called content, and the one after will be called, okay, it's very hard to page, and maybe the page can be null. Okay, so we create this content and this page, and here we can do what I wanted. So I want to, in the case of the content with page slot content, I want to, thank you, Copilot. I want to return the content, and which is a page. I want to put what the image can never be equal to this content. Okay, because what? Okay, that's a demo effect. What did I do wrong here? What? Content with the slot. Oh, Okay, because I misspelled the thing. Okay, sorry for that. Okay, so here. Then we have to create we have to implement the create render object method, and we don't have to put the widget here because every widget, the child will be take care of by Flutter. So if we have a property, if we add some non-widget properties, we have to give them to the constructor of the render object. But because my properties here are only widgets, we won't have to do that manually. Flutter will take care of them for us. And I won't override the update render object method because the Flutter already take care of this for us too, because it's only widgets properties here. So then, okay, because I make a mistake here, I have to change. Where is it? Okay, here. Okay, and if I save, and I want to quote that, if I save, I should have, because I don't have the terminal here, but I should have an error, but that's not the error I want to have, sorry. Okay, so we should have an error because, oh, I didn't save that. Okay, now we have the error I wanted. So this is, you can have this error when you don't set the size in the perform layout method, like I tell you before. So for that, we just need here, for the moment, to not to return something, but to set the size, and we want to set to biggest. Okay, so now there is again something not going good because we should not see anything. Okay, I don't know what's going on, but okay, because it was paused. Okay, and now, okay, we have nothing on the screen, but it's normal because I didn't do anything in the render object widget, render object. So what we want to do here, to fetch the content and make sure it exists. So we have to get it, and we can get it with the method child for slot. Child for slot return nullable render box. So even if we know that it won't be null, we have to make sure it is not. So if content is null, okay, size so smallest, I want that, okay. And then I have to lay out the content, and to do that, we just have to call a method on our content here, not layer, layout, okay. I have to give it the constraints, and I have also to tell it that we want to use its size after that, so that by saying it, Flutter will know that it will have to call again perform layout when the size of the child will change. So layout the content and use its size as the size of this render object. So we just have to do, thank you, Copilot, that. So the size of our widget will be the size of the content here. Okay, if I save, there is still nothing in the screen because I didn't create the paint method. So for that, I have also a snippet, and I will explain this. So here, we want to iterate through each children to paint them. And each children has the parent data I explained previously. And if it's a box parent data, we can paint it and get the offset stored in the box parent data. So now if I save, I should see the content. Okay, it is respond to the content size. So now let's lay out the page now. So the page, I will get it from child for slot and by saying it around the page. And if page is null, we don't have to do anything else, so we can return. The size is already taken care of here, so we can return as is. And if I save it, why don't I see the page? Oh, okay, because I didn't lay out the page. I want to lay out the page, constraints, and here, okay, we see the page, but it's not at the position I want. It's by default, it's at 0, 0, so it will be at the top left of the render object. So now to position it, I have to get the size of the content here, and X is, so it's the size of the content size, width, 2/3, I wanted, okay. And then I have to get the parent data of the page to put this information in there. Parent data, okay, and if parent data is a box parent data, what I want to do is to set parent data offset x0. So if I save, okay, it's all right. So then we have our page, and this page is only is always positioned at 2/3 of the content here. So that's all. Okay, we succeeded to do it. So let's take back here. So it's finished. So thank you everyone for this. And